Okay, so we're going to continue with the lesson, and this time we're going to work through some information on tree diagrams. So tree diagrams are used to list the sample space for experiments with 2 or more steps. So it's another good way of displaying the sample space like a two-way table when there's multiple things happening. So the outcomes for each stage in a tree diagram are listed on each branch, and the probability can also be listed on the branch. And we find the total probability of the outcome by multiplying down the branch, and I'll show you what that looks like. So here's a couple of examples. So we've got the first one is tossing a coin 3 times with replacement. So we've got one coin, we toss it, we grab it again, we toss it again. So the outcome is even for each possibility. So we've got an even chance of getting a head or a tail. So that means the probability of getting each one of those is half. Now it's important at this point that all of your probabilities on your set of branches adds up to a half. So, adds up to 1. So a half plus a half equals 1. Again, each set of branches on its own. So even though there's 2 sets in this column, each set still adds up to 1. Now, when it's even like this, you don't actually have to strictly write the probabilities on there, but I wanted to do that to show you show you how we can multiply down there. So the outcomes here is the first one. If we follow down here, just let me get another color of my pen. It's not ideal. Right, not sure what's happening there. Hang on one sec. Okay, draw. So if we follow down this one, our first outcome is a head, then a head, then a head. So our first outcome to this list that we can see is head, then head, then head. The second outcome would be a head, then a head, then a tail. So you have to follow each set, and it's easiest to do that when you go down and do it vertically like this. So half times a half times a half, because the chances of getting a head is 1 out of 2, then the next head is 1 out of 2, then the next head is 1 out of 2. So the chances of getting a head, then a head, then a head in this total experiment, you find by multiplying all those probabilities together. So that's 1/8. Okay, same as what we've got here. So that was an example with replacement. Now this next one here is an example without replacement. So you can see we've got a 3-branch tree diagram in the first section, and then it goes down to 2 branches, and the total outcomes are here. But it doesn't change the situation. You don't have to have even number of branches. There are a couple of tricks that you need to keep in mind. So you need to check that once you've worked out all your outcome probabilities, you need to check that they all add up to 1. So in probability, 1 is often the magic number that you're checking back to. And in this case, each branch is equally likely to happen. So if you see a tree diagram with no probabilities listed on them, it's because each branch is equally likely to happen. So hopefully that answers any questions you might have had about that. So, but tree diagrams can be useful. In fact, they're even more useful when outcomes are not equally likely. We still work them out the same way, but in this case, you must have the probability of the outcome written on the branches if they're not equally likely. So let's have a quick look at another example. Okay, so we're going back to the 2 coins example we had right in the two-way tables. So in that case, we assume the coins were fair. You've got an equal chance of getting a head or a tail. But what if the coins were not fair, or they're weighted more to one side? In that case, we might see a different outcome. So here's some information about that. So in coin 1, the chance of getting a head is 0.7. And in coin 2, the chances of getting a head is 0.6. So there are probabilities. We need to write these on the tree diagram and use them to calculate the probability of each outcome. So the chances of getting a head is 0.7. The chances of getting a tail then is 0.3. because remember I said each set of branches needs to add up to 1. That's also true here. So that's coin 1. In coin 2, the chances of getting a head is 0.6, which of course makes the chances of getting a tail 0.4. So again, you can see each set of branches adding up to 1. So these are our outcomes that are listed. Let's work out the probability. So again, we multiply down the branches. So the first one is going to be down here and then here. So we've got 0.7 times 0.6, 0.42. Next one, 0.7 times 0.4, 0.28. Now we're going to head down the tail branch, 0.3 times 0.6, 0.18, 0.3 times 0.4 is 0.12. So if I added up all of those probabilities, I would still see that they're 1, and I can use them to work out the outcomes, but you can see they're quite different than if the coin was fair. So again, multiply down the set of branches to get the probabilities of the outcome. It doesn't matter if the probabilities are equally likely or if they're weighted differently, the process is exactly the same.